That range number sitting on your dashboard is an illusion. It assumes perfect weather, a perfectly flat road, and a perfectly efficient driving style. In reality, the moment you put the car in drive, environmental resistance and hardware inefficiencies drain your battery faster than the manufacturer estimated. We are going to lock down your setup to reclaim those lost miles. We will run through a strict protocol to optimize your physical hardware, configure your onboard software, and adjust your kinetic driving inputs. By executing these steps, you can recapture 10 to 20% of usable battery life, extending your effective distance by dozens of miles per charge. To get started, you need 4 things: your smartphone with the companion app, an accurate tire pressure gauge, your car keys, and the vehicle itself. Extending your range requires identifying and sealing invisible energy leaks before the tires ever touch the asphalt. Step 1 is securing the hardware baseline. Open your driver's side door, check the manufacturer's recommended tire pressure on the jam sticker, and inflate all 4 tires to that exact specification. This diagram illustrates rolling resistance. When a tire is underinflated, the contact patch flattens too much against the road surface. The rubber flexes and deforms as it rolls, and that physical resistance bleeds your kinetic energy away as heat into the asphalt. Next, walk around the car and remove any empty roof racks, bike carriers, or heavy cargo from the trunk. You want to strip away every pound of unnecessary mass and smooth out the aerodynamic profile. Now, leave the car plugged into the charger and open your smartphone app. From here, activate the cabin preconditioning to heat or cool the interior to your target temperature. Climate control systems demand a massive amount of electricity, often drawing over a kilowatt of continuous power. By running the HVAC while the car is still tethered to the wall, you cool that heavy load directly from the electrical grid instead of your onboard cells. By preloading this thermal energy, your chemical battery starts the trip at 100% capacity, reserving its power strictly for forward momentum. Step 2 is locking down the software architecture. Get in the driver's seat and immediately lock the drive mode into Eco. Look at this chart comparing acceleration curves. Standard mode allows steep, aggressive power spikes that drain the battery quickly. Eco mode physically alters the throttle mapping, restricting immediate power delivery and spreading it out over a gradual arc. This protects your reserves from inefficient microspikes every time you tap the pedal. Next, turn to the climate menu. If you are alone in the car, isolate the airflow by selecting the driver-only setting so you aren't spending energy to heat or cool empty passenger space. If you are driving in cold weather, take this a step further. Turn down the forced air cabin heater entirely. Rely on your heated seats and steering wheel instead. They use highly efficient resistive heating elements placed directly against your body, requiring a fraction of the electricity needed to warm the entire volume of cabin air. Finally, find the regenerative braking setting and crank it to its absolute maximum level. Depending on your make and model, this might be called one-pedal driving or B mode. When you lift your foot off the accelerator, Max Regen reverses the mechanical operation of the drivetrain. The electric motor transitions into a generator, using the car's forward momentum to spin the internal magnets and send electrical current back into the battery pack. By dialing in these specific software parameters, your vehicle stops acting as a passive energy spender and becomes an active, self-regulating harvester. Step 3 is mastering the kinetic drive. When launching from a stop, drive as if there is a fragile egg sitting between your foot and the pedal. Apply pressure gradually, keeping the power meter on your dash as low as possible until you reach cruising speed. Once on the highway, establish a strict ceiling for your cruising speed, ideally keeping it between 65 and 70 miles per hour. This graph shows why that ceiling is necessary. The x-axis represents your speed, and the y-axis is energy demand. Up to about 30 miles per hour, your battery is mostly working to move the heavy mass of the car. But at highway speeds, aerodynamic drag takes over. You are forcing the vehicle to push atmospheric air out of its way, and the energy required spikes violently upward once you cross 70. Wind resistance increases exponentially with your speed. The penalty is not linear. Look at the massive gap in energy consumption between 65 and 75 miles per hour. Every single mile per hour over your threshold compounds the drain on your battery pack. To hold this efficiency over long distances, engage your predictive adaptive cruise control.
The software calculates micro-adjustments in speed far more precisely than a human foot, maintaining a steady pace without unnecessary power surges. Off the highway, adopt a horizon-scanning posture. Look far down the road to anticipate slowing traffic, yellow lights, and congested intersections well before you reach them. This anticipation lets you lift off the accelerator early. Coasting down gradually gives the regenerative braking system a long runway to recapture kinetic energy. Waiting too long forces you to use the physical friction brakes, which immediately throws that energy away as useless heat. Note that you should never shift your vehicle into neutral to coast down a hill. Doing so completely disables the regenerative harvesting loop and hands control over to gravity, sacrificing both safety and battery recovery. The pressure you apply to the pedals dictates whether your momentum is wasted to the environment or weaponized to push your range further. When you park at your destination, check your trip computer. This high efficiency rating is the direct mathematical result of executing the optimization protocol. By securing your hardware baseline, restricting power delivery through software, and maximizing kinetic recovery, you have pushed the vehicle to its absolute maximum theoretical range. Now that your daily efficiency is locked in, you need to protect the long-term health of the battery cells themselves. Click the next video on your screen to learn how the 80